Alrighty, welcome to SLiTHER number 17. Um, I am Chip Notaro, a member of the Leadership Council of Ionic Viper, and I'll kind of serve as our host today. Um, we've been doing this since July, August-ish. I believe I am the only person that can say they've attended all of these live at this point. So I see some new faces here, which is just great. Thanks for attending today. We should have a really excellent presentation from Kari Stone and Dan Kissel, having to deal with Gen Chem and some of the curriculum they have and how that had to transition into an online setting, which I think is great and unfortunately still very timely and topical. Before we get going, we do like to start these with a moment thinking about DEI. And I just want to very briefly mention that our last SLiTHER was by Benny Chan and Abby O'Connor, and they were talking a bit about some of the transformations they've done in the general chemistry and higher up courses at the College of New Jersey. And it really inspired me. I invited Benny and Abby to come and talk to my department virtually. And they did so just a little while ago. And we had a really good conversation. And particularly what I took home from it was just a little language barrier. Benny brought up the idea that he doesn't use the term office hours anymore. And, I've always struggled with getting students to office hours. And he brought up the idea that they don't know what office hours means. I'm like, yeah, you're right. It's a term we just throw around, but what does office hours mean? You're a student coming from a background where no one's gone to college. Office hours might mean, oh, this is the hour my professor in his office or her office, and I shouldn't bug them, or who knows what it means. So Benny really got me thinking a lot about, kind of that language and vocabulary that's just so commonplace to me that might not be so for students. So I'd encourage you to think about things like that. But with that, I'm going to turn things over to Kari and Dan for what's going to be just a great presentation. Please feel free to use the chat if you have questions, or, I'm sure Benny, I got Benny on my brain now. Kari and Dan wouldn't mind if you interrupted them, and we'll certainly have time for discussion and questions at the end. So take it away.
All right. Thanks, Chip. Let me go ahead and share my screen here and get our presentation up. And yeah, just like Chip said, we're going to keep it pretty informal. So if you want to ask us a question, definitely feel free to, interrupt us whenever you want. We're doing this as a dual presentation virtually. So, Kari is probably going to tell me to change slide just so but feel free to interrupt us and we'll be happy to answer any questions. Just to give you a little bit of background about where Kari and I work, we're both at Lewis University, which is a private Catholic Lasallian institution outside of Chicago, and Romeoville right next to Joliet. And the origins of those town names do go back to Romeo and Juliet. So we're about 6,000 students total. About 4,500 or so are undergraduates and the rest are graduate students. Our program in chemistry is decently large, I would say, for a PUI type of university. We have anywhere from 60 to 80 majors total at any point in time, and that includes chemistry and biochemistry majors. We have a pretty good relationship with our physics department. They're all fun to hang out with. So we decided to start an MS program in chemistry and physics jointly about 5 or 6 years ago. So Kari and I, we are educators in the undergraduate curriculum as well as the graduate curriculum. And being a Lasallian institution, we have a really large focus on service and service through education. And so we really believe in trying to serve our students as much as possible and being good educators and doing our best to make their educational experience really remarkable and memorable. So we're going to talk about some of the things we did transitioning into an online course for general chemistry because we had to. And just to show you, these are some pictures of our wonderful students. And to me, that is the best part about working in this industry and working where we're at is getting to interact with these crazy, silly kids sometimes, but it's a lot of fun for us. So obviously we all went through the COVID protocols and the COVID shutdown, and it really flipped our world upside down. It happened like a year ago, really. I mean, it seems like it was yesterday when this all started, but we've been a full year into this already. And so transitioning that quickly and moving your classes online, there were a lot of hurdles, a lot of obstacles. And, you know, it's hard to do things well, especially in the middle of a semester when you're transitioning.
So we all, do you mind if I?
Oh, go ahead, Kari.
So we all did this in about mid-March, right? And the sentiment from our administrators was, you get to work from home. And so, you know, that's why I put that up there. And then, and of course, we have an actual picture of Dan Kissel before he grew his hair out teaching in March.
That was early, yeah.
Yeah. So, I mean, so we all knew that the spring semester wasn't going to go as smoothly because, you know, if you were lucky, you got about a week to prepare to make sure you moved all your content online. And you had to learn technology really quickly. I'm infamous in not being able to figure out technology, so I had a really hard time. And so what we wanted to do is we wanted to make the fall semester better, be smoother than the spring semester. And so we had, you know, we decided early on that fall was going to be remote in all the chemistry classes. So we as a team, do you want to go one more? Thanks. We as a team, so there were three of us, Dan Kissel, me, and Amy Milnarski, who also works at Lewis University, decided, well, what we need to do is figure out how can we put together a course that not only will work for us in a remote environment, but also be translatable back to when we're face-to-face. And so really the obvious answer to that was changing the curriculum or the style into a flipped classroom style, where the content was delivered by asynchronous videos, and what we did in class synchronously was active learning and problem solving. And so that seemed like the best format for us because we can easily go back after doing all this work to put those videos online. It's easy to go back into, well, now it's going to be next fall before we're face-to-face again, into and using really the same curriculum that we built up over this year. So how this worked was we have a 4-credit general chemistry lecture course. And as instructors, there were 3 of us. And so we did a team instructor model where we had about 120 students, I believe, and we sort of just parsed them out equally. And we each ran about 2 or 3 synchronous sessions. All the content was posted online in a flipped classroom style. And we did something that was a little bit different, well, totally different than what we had done before. We switched to what you may know as mastery-based grading. You may have heard this as outcomes-based grading, specifications grading. They all really kind of mean the same thing, where we're teaching students how to learn, but based on a system in which the learning outcomes are their goal to master. Okay, and so this is a good way to one of the issues I hear instructors talking a lot about is, okay, so what if we give an exam and students cheat? There's a lot of talk about that, but in mastery-based grading, there's no real incentive to cheat because you're mastering the material rather than gaining points on a high-stakes exam. So we completely eliminated high-stakes exams. And this inspiration came from Santiago Toledo, who came to talk to our group. And also he gave a SLiTHEr, I believe in August, talking about what he has done to transform his methods of grading in general chemistry. And so I had been thinking about, and Dan too, about doing these types of grading, but it's always seemed like so much work to put together. Well, here with the pandemic, it was absolutely the time to do it. It was, it made sense in a remote environment, and we wanted to do it anyway. So we kind of just threw in everything we had ever done in Gen Chem and just like started anew. Everything was new. The curriculum was new, the grading was new, and the pedagogy was new. So, so think of the burning trash can down the flooded river. That's exactly what we did. Yes, that's us right there. That's, we're headed into fall. Good luck.
A lot of changes. And one of the things that, one of the reasons we decided to go to this, we really wanted to eliminate the burden on the students. And I don't know if you mentioned this, Kari, but the clue text we used, we wanted to make sure we were using a free textbook. So it was going to be no cost to the students. We wanted to provide them with the materials they needed, just because we were cognizant about the pandemic. And, a lot of our students come from middle-class families, and we just wanted to make sure we were being sensitive to their different situations.
Yeah. Okay. So thinking about this, why would you choose a mastery-based grading? Can you go back one?
Yep.
Yeah, thanks. All right. So the way this works is this is the framework that it provides a framework to align our assessments with student learning outcomes. Okay. So what we're doing with mastery-based grading is we are embedding opportunities for mastery of the material. We are aligning our assessments with those student learning outcomes, and we're leveraging the cognitive levels of understanding. All right, so the cognitive levels of understanding are shown here. So this is the Marzano's taxonomy, where retrieval is the lowest level of learning, and the knowledge utilization is the highest. So at the first year general chemistry curriculum, we are targeting comprehension and analysis as our levels of understanding. So here, the focus with mastery-based grading is on effective learning, rather than you don't just lose points, you gain or earn your grade. Focuses on proficiency. So how well did you learn this particular learning outcome that we wanted you to be able to learn in order to pass the class? And so instead of having high stakes exams, we had a series of what we call checkpoints. With these checkpoints, we are assessing whether or not the student has mastered that learning outcome. And the goal here is that the students will learn autonomy, and they'll have a grasp of how they earn their grade based on this level of understanding, this Marzano's taxonomy. Next slide. All right, so this is an example of a student learning outcome that I just took from one of our outcomes. And it's broken down into the comprehension and the analysis level. So in comprehension, this is the idea that maybe you just understand something. And so you might make relationships between the size of an electron cloud and potential energy, right? But analysis, that goes a step further. Here you're applying relationships. So, and you're predicting, you are ranking. So things like predict a relative potential energy of given atoms, using something that you have comprehended, like Coulomb's law or London dispersion forces. So this would be example of one of our student learning outcomes. Next slide. And this is an example of how we might align that certain student learning outcome. So this is 1.2 that we use. So this is an actual checkpoint that we used. And so they need to look at this figure. And in this figure, they have an x-axis that says distance from 0 to 10. And they have to look at these pairs of atoms that are color-coded. and they have to predict which is going to have the lowest potential energy. All right, and so they're going to assume that the partial charges are all the same, and so really they're just looking at the relative distances between the two. And so this would be an example of analysis. So they have to look at distances, apply Coulomb's law in order to predict potential energies. All right, next slide. All right, so how does this work out for the students? Well, it turns out the students are really anxious about their grades. And it's not just students. We were anxious about their grades. Their advisors were anxious about their grades. Our department chair was anxious about their grades. So, because this is what it looks like before the first midterm. Okay, so midterm is literally in the middle of the semester, and most of the class is failing. And the reason that is because the checkpoints are all or nothing. So you either master it or you don't. And so this was at the point where students hadn't gained enough mastery in order for that grade to reflect their knowledge yet. And so this created a lot of anxiety for the students. And what has to happen in this type of grading system is there has to be ample communication. There has to be lots of points along the way where you just ask students, what do you think? And we did that throughout the semester, where we would give formative evaluations to determine what's working and what's not working, because this actually was completely new to us, and it was new to them. And so anxiety all around for everybody at this point. All right, next slide. But there's always light at the end of the tunnel. By the time the students figured out how to gain mastery, they had a total of 4 attempts at each SLO at each level. So by the time they were able to get through those 4 attempts, most of them had mastered all of the SLOs at some level. And so we ended up in the class with about 64% A's and B's. So you can see the drastic improvement of students from midterm to final. And the thing is we as instructors were predicting, well, they just haven't gained mastery yet. You know, they'll get there, they have more attempts. The students didn't necessarily agree with that, and or maybe didn't believe us. And so there was a certain higher number than usual that withdrew from the class. So about 15 students withdrew. So this is the students that, you know, just gave up, and they didn't know that by the end they could be successful. And with that, so the students that kept on taking those checkpoints and getting through the material and just really kept going, they got A's and B's. So this really is a testament to, you know, student perseverance. You know, they were able to, in the end, hit it out of the park, and we were so proud of them. Oh, and at the same time, as instructors, we believe that the rigor remained constant through all the attempts. So one might say, well, you know, maybe you just adjusted your checkpoints to make them easier for them to master. And that's really not the case. We kept the rigor at what we believe to be the same level throughout the semester. All right, so go ahead, Dan.
So I'll just kind of summarize what we learned from the first semester. Really, the grade was really heavily on the checkpoints. So, you know, we came up with these student learning outcomes because we wanted to map everything back to those student learning outcomes. And like Kari said, the rigor was consistent because every checkpoint we released to SLO 1.2a for analysis, for instance. There was a very specific guidelines that the students had access to, which said we are going to ask questions about, you know, Bohr model of the atom, right, or whatever we're looking at in that SLO. And so all of our questions would always map back to there. So we were able to keep consistency with the rigor. And their grade was broken down into the checkpoints, and then they had a homework component as well. The homework wasn't worth as much points. They had to get 80% or more right on their homework to get the full, I think, 4 points or however many it was. And then we had the checkpoints, which are really the meat of the points they could get and for the mastery. And they had several opportunities. So we would give them at least 3 opportunities at every checkpoint. If they didn't master it the first time, they could go to a second. If they didn't master that one, they could try the third. And that's why they had a lot of anxiety, right? So we noticed that this anxiety was definitely an issue for them because at any point in the semester, they could have a D or they could have an A, right? Because we were bringing checkpoints back at the final, right? So in theory, they could improve by several letter grades if they wanted to. And this created issues with advising to a lot of our students were advised incorrectly, in my opinion, because the advisors outside of the chemistry department just were not familiar with mastery-based grading. So we saw that this anxiety was an issue with the all or nothing point system. And we also saw that the full flipped structure wasn't really working. There was no point system for the students where they weren't rewarded to show up to class. We told them to come to the problem solving sessions, but it was kind of hit or miss sometimes if they would come and show up. And we only had 1 problem solving session per week. And a lot of the feedback we got from students said, look, we need a lot more face-to-face interaction. And even halfway through the semester, once we figured this out, that we were getting this feedback, we started putting an outside of class problem solving session together. So on Thursday nights, we would host a problem solving session that was live with students so we could have more face-to-face interaction. Because that is definitely one thing that popped up quite a bit. And okay, Sean, I see you have, Kari already answered that question. So we were worried quite a bit about their anxiety. We were worried about them not getting enough face-to-face interaction. So we wanted to make some of those changes. And then we found that they really liked the synchronous problem solving sessions when they were in it. They wanted more of that, right? We were only doing it 1 day a week. Our class was so big, we decided to split them up and have half the class go on 1 day and half the class go on another day. But the students said that they wanted more of that. They wanted more of that face-to-face interaction, more of the problem solving. And so when we went into next semester, we decided we were going to change our plans a little bit. And we decided to change our structure so there were 2 problem solving sessions per week that were different. So now the students had to attend those 2 recitation sessions. And we had a 3rd session that was a content preview session, which is kind of more like a traditional lecture. In my course, I treat it like more of a collaboration time. That's what I tell the students. This is not me lecturing at you. This is our collaboration time where you come with questions, kind of like office hours, like Chip talked about, only it's scheduled in their schedule, right? So it's in the course catalog that we meet 3 days a week. 2 of those days were for problem solving recitation sessions, and one of the days was for this collaboration where they asked me questions. I asked them what they want to know, and they say, hey, can you talk about acid-base chemistry? We just got over acid-base chemistry. We were just talking about it last week, and one of my students was interested in lactic acid because he likes exercise. So we just came up with some acid-base work on lactic acid. I had him look up the pKa's, and we were just looking at the Ka values and doing some conversions and looking at the reactions and how the acid dissociation reaction would work. So I think it's kind of fun for the students where we could literally just talk about what they're interested in, but also as an instructor, you got to bring it back to the material. So that's one change we made. This created a partial flip class. So we still did the lecture videos, which are posted on a YouTube channel we created for our chemistry department and for the course. And so all the general chemistry students have access to the same videos outside of class. And we have them watch those videos going into the week. So we post them the Wednesday, the week before they're supposed to do problem solving on that lecture content. And usually at the beginning of the week, we have our collaboration content preview. And then the rest of the week, we do these problem solving sessions with them. And it seems to be working pretty well. So this we call it a partial flip because the lectures are still there, but we have this extra class period that's more of a collaboration with the students where we can go over lecture material. And then we got rid of the mastery system, the all or nothing mastery grading system, and we decided to implement a sliding scale into our mastery grading. And we thought that this would give students a better concept, better idea of where they are at. And also, we had problems with athletes because athletes need these reports from their coaches through the semester. And so, it's hard to tell a coach, yeah, they have a 30% right now, but they could have a 95, right? The coaches don't like to hear that, and the athletes don't like that either. So I'm going to show you what we did with our grading system. We decided to break it down. So for each SLO, our grading is based on mastering those student learning outcomes. So for each student learning outcome, there were the checkpoints, and we had homework and participation. So now we're awarding points for showing up and actually being there at those problem-solving sessions. We have our homework still in place that we hand out every week. And if they score greater than 80% on the homework, we mark that as proficient, and they get 4 points for that. If they score less than 80%, it's not proficient, and we give them a 0. And we're hoping that they use that homework as good feedback going into the checkpoints, because the checkpoints are released after the homework's due, after the homework key is put out for them. And then our checkpoints are 20 points total. They're separated into an analysis and a comprehension component. And you can see how we broke it down now. We broke it down into 4 levels of learning. If you have major concerns, right, and this we thought we would give students more feedback, you get a 0 out of 10. If you're kind of doing some stuff right, but it's not quite there, we would give you a needs improvement, which is 5 points. A lot of students the first semester were getting really close to perfect answers, but just making a small mistake. And so they would get a 0, and that would cause a lot of anxiety for them. So now if a student does that, we can put them at the still learning level, and that's awarded with 7 out of 10 points. And then if they get it totally right, we give them a proficient score, which is a 10 out of 10. Now, how do we determine these levels of learning? Well, we have a rubric for that. So we use a rubric for our analysis checkpoints, and we use a rubric for our comprehension checkpoints. And so you can see how we break down the checkpoint grading, where we look at for completeness, correctness, analytical problem-solving skills, the computational approach, and then the conceptual understanding. Because in the analysis problems we're doing, and part of the CLUE curriculum is really based on making predictions or making claims supported by evidence and reasoning. So we're really trying to see evidence in those calculations and reasoning, connecting the math to the conceptual understanding and what they're doing. So our checkpoints this semester are all, each checkpoint is 3 questions. They're multiple choice questions. So we can look at their multiple choice answers, and then we have a 4th file submission question where students have to upload the work that they do for the multiple choice questions. And a lot of those multiple choice questions, we say, specifically write this reaction in your file submission, do this calculation. And we want to see that they're not just getting lucky and guessing the answer. We're looking for those levels of understanding where they're really doing the math right, setting the calculation up right, getting that conceptual understanding.
Hey, Dan, I just 1 second. So that's actually a really good point. So I've graded some of these SLOs where they get the right answer, but their work doesn't match their answer, or their reasoning for their answer doesn't make any sense. So that 4th submission is really crucial here.
Yep, and all the points are, the rubric's tied to that 4th submission, right? And that's really what we're looking for a lot of times when we're doing these rubric grades, is we're looking for their work. And we can come up with these levels of learning based on their rubric score. So, in our learning management system, which we have Blackboard, we can put this rubric in there and score the checkpoint based on the rubric, and then look at the total that comes out. So if they get all 10s, that everything's proficient in all categories, that's a score of 10. So that gives them at proficient. They've mastered that. They don't have to take it anymore the rest of the semester. If they score somewhere between 7 and 9.99 on the rubric, that's still learning. So we assign them a score of 7. Now, they will have a second chance at this SLO if they want, right? Their score can only improve. It can't go down in the mastery-based learning. So one thing we did, because we're doing these levels of learning now that are, and it's not all or nothing, we're decreasing the chances they have for mastery. We're only giving them 2 chances to master the concept, but they can still only go up. They can never go down. And then, of course, if you get a 5 to 6.99, that's a needs improvement, and anything less than a 5 on the rubric score gets a 0, major concerns. Now, another thing we really wanted to implement, because we started looking at other mastery grading-based systems to see what other people were doing in the literature. And one thing we wanted to implement was a way for students to be rewarded for trying to improve themselves. So we created what are known as learning enhancement opportunities. And we kind of started this the first semester already when we got that feedback from students asking for more practice, more face-to-face interaction. We did the problem-solving session. So every week we do a problem-solving session now at night. I'm doing the one tonight. It's going to be at 8:30 tonight on Zoom. In case you're not doing anything while you're sitting down with your cocktail, you want to hop on and talk about acids and bases, I'll be there. And you can get rewarded for these LEOs, right? So if someone doesn't score proficient on their checkpoint, they can attend a learning enhancement opportunity and get a point added to their score. A learning enhancement opportunity is attending the weekly problem solving session, or if they get virtual tutoring, our university offers tutors that they can go through the university system to schedule. And those tutors will email us to let us know they had an appointment. So if they go outside of class to get a tutor, we will give them the learning enhancement, the LEO point, for trying to better themselves. Or if they show up to the problem solving session, we take attendance before and after, and we will give them the LEO point. They can get a LEO point for their homework if they score a 0 on the homework, or for their checkpoints, right? So if they don't get proficient on the checkpoint, they attend the problem solving session. The idea is that they'll learn more by trying to improve themselves. So we want to reward that. So one thing that we didn't talk about that we did last semester, which we really liked, was class projects. So we're kind of going to, before we go over more of the data and the assessment, I'm going to let Kari talk a little bit about the class project we did in the first semester. And we're also continuing a class project this semester, but it's a little different. We can talk about that later.
All right. So what we wanted to do going into the fall semester is we wanted to have the students have a sense of community. And when classes are face-to-face, that's a little bit easier to do. But virtually, we were struggling with how are we going to be able to have students interact with each other. And so one thing we decided to do was to have a required common read. And this book, The Disappearing Spoon, I am just assuming that many of you at least heard of it, if not have already read it. It is a wonderful book, and it literally tells the story of every single element on the periodic table. And I can't sing its praises enough. Sam Keen is a wonderful storyteller, and he does know his chemistry for sure. And so the students were supposed to read this book, and the requirements were that they would read a chapter a week, which is about 10 to 15 pages of the book. And then they were supposed to post a discussion post on that particular chapter. And the reason we picked this book is not only because we love Sam Keen, but because in Gen Chem 1, you're primarily learning about the periodic table. There's so many spots where it's like you need to know and be able to navigate the periodic table. And so this seemed like a really nice fit for students to read. All right, and so could you go over one more slide?
Yeah.
And so part of this project culminated into what we're calling an interactive periodic table. So the idea is that the students would read this book and they'd read all about the elements, and there would be some element that stood out to them as, oh, I want to know more about that. Well, hopefully they don't all get the same idea and pick gallium. They didn't. We had a Google Sheets where we put down all the elements and the students would pick the element, and it was first come, first serve. So the students that were really on top of it would literally picked the first week what element they wanted. But there was a deadline in which they were to pick their element. And what they needed to do then was to research their element, prepare a PowerPoint presentation or a Google presentation, and post it to Blackboard or a Dropbox link, I think. And this is them, and the video that they made was about the history of the element, fun facts about the element, what it's useful for. And I have to say, so I graded, my whole section's worth of videos, and they hit it out of the park. This was so awesome to see their videos and see what they came up with. I even have an example of a student sitting fireside with his Christmas tree in the background, telling me the story of his element. It was really, really awesome.
There was some soft jazz in some videos. It was a very nice touch.
Yes, I thought it was a great production. So why don't you go ahead and show us what they came up with, Dan?
Sure. Does anybody have an element they want to look at in particular? Do you know of a good one, Kari? One that stood out more than?
I'm not sure. Why don't we just do one of my favorites, arsenic? Oh, no. Do radium. I remember that was a really good one. She got into
radium.
Yep. Radium. Yep.
Okay, give me 1 second. So just to show you, this actually, it lives in a Google Sheet. So this is where our living interactive periodic table is. And we plan to project this onto televisions in our department that are touchscreen, so people can literally click on what they want and the video will come up. And so after the advertisements here, if there are some, we're going to go straight into it. Okay, hold on a second. We can go ahead and watch this.
Hi, my name is Monica, and I did my project on the element radium. So radium is considered to be one of the most well-known radioactive elements.
Dan, do you want to speed it up to 1.25?
It's the element, and it is an
hold on, sorry.
The most well-known radioactive element.
I think it's under settings. Yeah, playback speed. Yeah.
1.25, okay.
Yeah. The students tend to talk very slow, so I always had to speed them up.
Element, and it is in group 2 and period 7 of the periodic table. So it's also considered an alkaline earth metal, along with 5 other elements. This group of alkaline earth metals is all considered to be reactive to a certain extent, radium being the most reactive due to its radioactive property. Although it is known, radium is known for how radioactive it is not the most radioactive element. The most stable isotope of radium is radium-226, and it has a half-life of 1600 years. In its pure form, radium is silver and white in color. However, whenever it's exposed to air, specifically nitrogen, it forms radium nitrate on its surface, which gives it a darker color. The melting point of radium is 973 on the Kelvin temperature scale. Its boiling point is...
Go to History of Radium.
The novel, The Despairing Spoon. From the novel, we learned that Mary Skłodowska-Curie and her husband Pierre discovered radium in December of 1898 in Paris, France. Radium, along with polonium, was actually discovered as a waste product of the uranium ore, which is also known as uraninite. Radium is considered 1 million times more radioactive than uranium itself. And in the early 1900s, it was widely used in manufacturing to give it a luminescent factor in paint. This paint was used to paint walls. Some women used it on their fingernails, even put it in their hair. And back in the day, they did not know how severe the health side effects of radium were. At one point, it was even considered a cure-all because a physician discovered that radium kills or targets cancer cells. So they believe that it could also treat other diseases like tuberculosis. So as interesting as the radium element is itself, I think the history of radium is even more so fascinating. So in 1917, there was a corporation called the United States Radium Corporation that hired women ranging from ages from 11 to 6 years old. And they were all instructed to paint watch dials with the radium luminescent paint. So approximately 70 of these factory workers who worked in facilities in New Jersey, Connecticut, and Illinois were all exposed to radium via ingestion. So yes, they physically ingested radium in their mouths. And that was because the corporation had advised them to lick the paintbrush tips when they were painting the dials in order to get more precise paint strokes. This corporation was pretty corrupt, and they withheld information about radium side effects, and they even went so far as to hire health experts to associate the severe symptoms to syphilis rather than radium ingestion. And unfortunately, these women did not receive any reparations from the corporation. And the financial reparations that they did receive only covered the extensive healthcare bills they had to pay due to the radium poisoning. Even more unfortunate is these radium girls, also called the Society of the Living Dead, received a lot of backlash from the public, especially the other factory workers, because they were paid well. And so if these women continue to sue, the corporation will go bankrupt and close. So they didn't really receive a lot of support from the public.
All right.
All right, yeah. So you can see that some students really got into it. I love that picture of the radium dial. Did you see that? Yeah, so she did a great job on this one. And she takes these pictures from the book Radium Girls, which is an awesome book too, having to do with the element radium. So
yeah, there's also a play, I think, now too.
Yep.
All right, so the students, they had a lot of fun with this, and I'll let Kari kind of go over the assessment results from everything.
All right, so we evaluated the students, not evaluated, we surveyed the students based on the course and also based on that final project. And so the first question we asked the students, which I put this in here because I thought it was interesting because I've never seen students be able to predict their grades so well. As you can see from the final grades, they were able to say they had primarily A's and B's here. So I think that speaks to the kind of feedback they were getting, the kind of communication that we were giving them all throughout the semester.
And there's that final grades right there, just to reference you. They're all right on the percentages with what they predicted.
Yeah. So that's the grade they expected to get. And then what did they say? So we created a word cloud to see the words that came up during their comments. So these are the individual student comments. So what's your favorite part of the course? Things that stand out to us are the periodic table project, the disappearing spoon, learning. I love that they like to learn, things like that. So it was really clear to us what their favorite part of the course was. It was definitely that the disappearing spoon and the periodic table project. That was definitely their favorite part. And of course, we asked them what their least favorite part of the course is, and you can see that comes out. So really, really big is checkpoints. And then of course, some people didn't like reading the disappearing spoon. So that was kind of a mixed bag on whether they wanted to read it or not. But the students that actually read it had really good things to say about it. And you can see the checkpoints are big, and then the pass fail. So that was another thing that was creating anxiety for them. All right, next slide. All right, so this is some of the evaluation data. So this is all on a Likert scale. One of them was these questions about how effective things were, and the other was, do you agree with these statements? And so it's kind of a couple things I want to point out is they were very happy with the chemistry instructors putting the content online, being available for office hours, effectively improving their learning. So even though there were so many parts about this class they didn't like the checkpoints and that they didn't see us as often as they wanted to, they were still really happy with their instructors and that we were able to make time for them when they needed it. All right, next slide. All right, so what did they say about the class project? Well, interestingly, most of the students read most of the book. I was surprised by that. I thought it would be a larger percentage that read less than half. So I'm glad that the students, even if they didn't really like reading the book, that they actually read the book. All right, next slide. All right, so what did they say about the reading the book and the class project? So one thing that stood out to me is, and this is really the focus of the book, is that reading the book has taught me new things about how chemistry and its history, well, it looks like we didn't finish a sentence, but chemistry and history. So they really liked making the YouTube video. They really liked researching their element. And they appreciated the history that was in the book itself. All right, next slide. All right, yeah, Deanne, good point. They also thought that the reading the book and posting was a lot of busy work. But I would say that also in the end, they appreciated doing it by the time they got to the interactive periodic table project, because it came together for them a little bit better. Mm-hmm. So these are student comments regarding the interactive periodic table project. So they said things like they that they enjoyed reading Disappearing Spoon more than they thought they would. So that's kind of funny. That they liked doing the periodic table project. They could work at their own pace. That it didn't really feel like an assignment. So I thought that was a kind of neat comment, that they didn't feel like it was an assignment, that it was just kind of fun to do. And this was happening during the last week of classes. And one student actually commented that it was kind of a relief to do something else besides study for finals. All right, next slide. All right, so this was our attempt at throwing everything out the window and starting anew. So we just burned the house down and built it up. And so how we attempted to do this is we had, along the way, we had to do formative assessments. We had to know where the students were at. We had to ask them the questions so that we could, in time, adapt to what they needed. And I think we did that really well. One of the things we did mid-semester was we implemented another problem-solving session that they could attend to get more of the engagement with the content. And we used the final evaluation survey to inform what we did second semester. And we showed you all the things that we did going into second semester. And right now, I can say without a doubt, and I'm sure Dan says this too, that things are going great. I think we're nailing it this time, Dan.
Yeah, the adjustments we made, I think, are really good. And like Kari said, this all goes back to communication and really communicating well with your students, especially in these online formats where it's stressful for them, it's unusual. And we were able to adjust really well, and the second semester has been going great so far. So I think that it's been a good experience for the students and a good experience for us. And, just like anything we do in science, we just continue to take data and adjust and make it better if we can.
Mm-hmm. All right. And with that, we would definitely entertain any questions that you have. I've been responding to some questions over chat, but what do you have, or any insights or comments, anything?
I have a question. So are all of your students on the same content at the same time? So is the full class moving together, Or are some students still working on a previous SLO while some people have moved forward? Like, how do you manage the timing as you work?
So last semester and this semester, we are completely on the same page.
Okay.
Everything we do is exactly the same. They even take the same checkpoints. They watch the same videos. Everything is the same except for the problem solving sessions. They work on the same activity, but of course they have different instructors.
Right, and they have they release the checkpoints at the same time for all the students. So if a student needs a second attempt, but another student doesn't, then that other student just doesn't take it the next time.
Got it.
I assume there was, oh, go ahead.
Oh, I was just going to add to that. It was really helpful to do a team-based approach to do this, because if you throw out everything you've ever done in Gen Chem and have to start anew, it's really helpful that you have people that can help you work on content, work on videos and all of that. So I don't think anybody would ever do this if they had to do it all on their own.
It is an incredible amount of work.
Yeah.
And it's like, it's all in the preparation. It's an incredible amount of work and preparation. Once you have it in place, it goes well. But because we attack it as a team, we kind of rotate on and off content. So, one person will be on for certain content where they're making the videos, they're doing the problem solving sessions, they're getting the homework together. Got one more week, and then I rotate off content, and I'll be able to sleep a little more. Right.
Yeah.
So
yeah. It is rough when you're on content. Yes, it is.
I have more questions. If you have what, sorry, I didn't want to interrupt if you have one.
That's okay. Maybe we can alternate.
Okay, you can go then.
Okay. I'm curious about the SLOs, and I was kind of surprised actually at first when in the chat, the answer was 10, because I was expecting more, and maybe that's just because this semester our Gen Chem, or this year I should say, we're trying the OpenStax, textbook, and in the OpenStax textbook they have written out learning objectives at the start of each sort of subchapter, but they are sort of like, they tend to be quite specific, and there's multiple per subchapter. So by the time you amass all of them at the end of the semester, it is pretty lengthy. So I don't know if you have any commentary on that. Like, are your SLOs very broadly written?
They are.
Okay, all right.
They're very broadly written, and what you need to if you jump into something like this, what you need to consider is there can be too many SLOs. It just creates a lot more work. So I think what we've settled into is that if we could do one a week, and so remember, every SLO has 2 levels to it. So if we could do one a week, that's actually a perfect, that is a perfect system, because every Sunday night they're working on their checkpoints. Yeah. And we do this every week, except for, like the midterm, and if there's weeks that we review. So it's probably more like 12 in the end.
Yeah, and I think the slows are broad, and everybody writes slows differently is what I've come to learn, right? And it's like, we try to have university-wide student learning outcomes, and so those are super broad, but our student learning outcomes will have several goals within them, right? So some people write goals as separate student learning outcomes. We try to write a broad student learning outcome with like 10 goals in there. And I think that's a little better for the questions we ask, because, we can ask these more complex problems where they're pulling on several different things. Writing an acid-base dissociation reaction, also, calculating the constant, converting to KB, right? So you can hit several of those goals within a student learning outcome, and you can write different questions for the second time around that are still related, right? By having that broader SLO.
So we're at Temple also currently in the middle of applying mastery-based in Gen Chem, in both our Gen Chem 1 and our Gen Chem 2. So I'm really interested in how you guys are doing it versus how we're doing it, to see the comparisons. And one of the things we really struggle with is this like consistent contact with students piece, that you need to kind of like be constantly like talking with them and emailing them. So I'm just curious how your instructional team is managing that. Like, how are you breaking down being in contact with students all the time?
It's going a little bit smoother this semester because we actually have where they're broken into sections now. So before we were just divvying up the work because it was all one section, but now we actually have our own sections, and so we individually manage our own sections. But as far as having to communicate with students, because the amount of anxiety is so much less with the sliding scale, it's not as much of a problem. Last semester, I mean, we were writing emails all day long. So,
and the system we had, it was kind of difficult for them to calculate their grade because you couldn't keep that system in a learning management system, really, right? Like mastery-based grading doesn't work well with learning management systems. So the students had no clue. They were just totally oblivious. And we made them a video to show them. We made a spreadsheet for them. We made a video for them to show them how to use the spreadsheet, and it was still too complicated. So we tried to really simplify the grading system. And the one we use now, because it's slotted at different levels, it integrates better with the learning management system, and it's easier for them to really understand it and conceptualize it. And we each are in charge of our own group of students, right? Our own group of like 20 to 30 students. But we communicate with them, not just through email in class, but we have a Slack channel that we use for general chemistry that they're all on. And some people are better about it than others, right? Amy for us is really good, but it's just one too many app for me. So every once in a while I'll get on, but they have multiple ways to contact us and communicate with us.
I guess I don't know. Maybe I'll just try to formulate my question as I chat here. But so one of the issues that I'm running into in my class is so on our assessments we will actually sometimes have like a follow-up question. It's almost like kind of like a built-in curve-ish into the assessments to sort of just have them. We ask, what are the learning outcomes associated with this question? And surprisingly, even though I emphasize almost daily, every time we have a class meeting, what the learning objectives are for that particular class meeting and that problem solving set. On the assessment, students will it seems like they don't quite know what the learning outcomes are. It's maybe a little less than half the class, but they might write their own, or they'll just write a list of topics. So I don't know if you've encountered that. Like, do students ever lose sight of your SLOs, or is it like so embedded that you don't really have that issue?
I think the mastery-based grading helps that a lot, because before, students are so concerned with their grade and the percentage, right? Like pre-med students or whoever, they don't really care about what they're learning. They care about getting the grade. And when you have this mastery-based grading system that's based on their ability to master the concepts, then they take more of a vested interest in learning the concepts and understanding them.
Mm-hmm. Cool, thanks.
Can I sneak in just a quick, I assume there was a lab associated with this of some form. Was that like a major lift for them, and that's where you were getting resistance in the element project, or?
So the lab portion of the course is completely separate from the lecture. So the lab people were doing their thing and we were doing our thing. The anxiety really came from the grading, and the students didn't understand their grade or didn't know how to calculate their grade. And at any one time in the semester, they could be completely failing, but that doesn't mean that they're a failure. Yeah. And so that's where the anxiety came from, and not only from the students, but from colleagues who were seeing the students complaining about the grades, and in some instances, advising them to drop the course. So Yes, there was a lot of education involved, not only for the students, but for our colleagues.
Yeah, we've kind of we kind of decoupled the lab for general chemistry a few years ago because we wanted to change, especially with the Adams first approach. It was tough. So our first semester Gen Chem lab is mostly like a skills building lab where we're trying to build up skills, and then second semester is like a cure lab where they're doing more research based projects.
All right. Any other questions or comments or thoughts? All right. Well, our next SLiTHEr is going to be in a few weeks, and gosh, some terrible person is doing it. Oh, it's me. The 25th, I think, is what I'm scheduled for. It's going to be on switching to a LibreText for my inorganic class this spring is the topic. With that, I want to thank Kari and Dan for just a really great and interesting talk.